Assalamu alaikum. Today we want to explain the second part of hydrocarbons, the alkenes. The objectives are recognize alkenes, apply IUPAC to give names for different alkenes. First, we know the hydrocarbons are compounds consisting of carbon and hydrogen only. They are represented by the general formula CXHY. The hydrocarbons are two parts, saturated hydrocarbons and unsaturated hydrocarbons. The saturated hydrocarbons are the alkanes. The unsaturated hydrocarbons are alkenes and alkynes. Introduction. An alkene is a hydrocarbon of general formula CnH2n that contains a double covalent bond between two carbon atoms in the carbon chain. Hence, it is unsaturated. The presence of double covalent bond indicates that the hydrocarbon is an alkene and it is an unsaturated hydrocarbon. So in the nature, we saw that the formula of the alkenes is represented by this form. Nomenclature. The name of the alkene that has the longest carbon chain containing the double bond is derived from the alkane that has same number of carbon atoms by replacing the suffix "ane" by "in". Example, C4H10 and C4H8. Here, the two molecular formula have the same number of carbon atoms. So the prefix is the same for the two molecular formula. But because we have 4 carbon atoms. But here we have 10 hydrogen atoms, and here we have 8 hydrogen atoms. So the first molecular formula obey to the general formula CnH2n plus 2, yani 2 times 4, 8 plus 2 equal 10. So the nomenclature, the suffix of the nomenclature is ane because it is a butane. But here we have 8 hydrogen atoms. So this molecular formula obeys to the general formula CnH2n, 2 times 4 equal 8. So it is an alkene. So that the suffix of the nomenclature is in. And the table represents the nomenclature of the alkenes. The condensed structural formula of ethene C2H4. First, we put the 2 carbon atoms and we put the double covalent bond between them. And we must distribute the hydrogen atoms between the 2 carbon atoms. Here, we must pay attention that each carbon atom needs 4 bonds to be stable. So, the first carbon atom make 2 bonds, and it needs 2 bonds to be stable, so it needs 2 hydrogen. And the second one is the same. So the condensed structural formula becomes CH2 double covalent bond CH2. For the propene C3H6, first we put the 3 carbon atoms and we put 1 double covalent bond between 2 carbon atoms, and the other carbon atoms we put between them, we put a single covalent bond. Yani in condensed structural formula of an alkane, we have 1 double covalent bond and the other bonds are single between the carbon atoms. The first carbon atom make 1 bond. So each carbon atom needs 4 bonds to be stable, and it make 1 bond, so it needs 3 hydrogen. The second one make 3 bonds, 2 here and 1 here, 1 there. So it make 3 bonds, so it need 1 hydrogen to be stable. The third one make 2 bonds, and it need 2 hydrogen to be stable. For n bigger than 3, number the chain so as to include both atoms of double bond and begin numbering at the end of each chain near the double bond. Example C4H10. First I want to take the straight chain and I want to give the name of each of these two condensed structural formula. I want to take the longest chain and I want to begin numbering near to the double covalent bond. So the longest chain is containing 1, 2, 3, 4 carbon atoms, and I want to begin numbering nearer to the double covalent bond. So from here, 1, 2, 3, 4. The nomenclature of the first condensed structural formula is 1-butene according to the position of the double covalent bond on the first carbon atom, and butene because we have double covalent bond. It is an alkene. For the second condensed structural formula, the same. We must take the longest chain 1, 2, 3, 4, and I want to begin numbering nearer to the double covalent bond, so I can numbering from here or from there because the double covalent bond is put in the middle of the chain. So the double covalent bond is on the second carbon atom. The nomenclature is 2-butene. Branched alkene. When the carbon chain of the alkene is branched, indicate the location of the substituent groups: methyl CH3, ethyl C2H5, propyl isopropyl C3H7 by the number of carbon atoms to which they are attached. Example, we want to take the first one and I want to begin numbering. First I want to take the longest chain containing the double covalent bond, so I can take 1, 2, 3, 4 or 1, 2, 3, 4. Second, I want to begin numbering nearer to the double covalent bond. So the double covalent bond is put in the middle of the chain, but here I have a group method. So I want to pay attention here that I want to begin numbering nearer to the double covalent bond and nearer to the group method. So I cannot begin numbering from here because the methyl become on the third carbon atom. But if I begin numbering from here, the group methyl is put on the second carbon atom, and the double covalent bond is also on the second carbon atom. Like I say before, that the double covalent bond is in the middle chain. So the nomenclature is 2-methyl, 2-butene, 2-methyl, 2 according to the position of methyl is on the second carbon atom, and 2-butene, 2 here according to the position of the double covalent bond also on the second carbon atom. Here I want to begin numbering nearer to the double covalent bond, so from here, and we have a group methyl is put on the fourth carbon atom. So the nomenclature is 4-methyl, 2-pentene. Application 1. Write all the isomers condensed structural formula of C5H10 and give the nomenclature of each one. First, I want to take the straight chain and I want to change the position of the double covalent bond. First, I want to put it on between the first and the second carbon atoms, and here between the second and the first. And I want to begin numbering nearer to the double covalent bond, so I want to begin numbering from here. We have 5 carbon atom and the position of the double covalent bond is on the first carbon atom, so the nomenclature is 1-pentene. And here the position of the double covalent bond is on the second carbon atom, so the nomenclature is 2-pentene. Now I want to take the branched chain and I want to take the first chain by respecting the position of the double covalent bond, but I want to make a ramification. I want to make a group methyl here on the third carbon atom, because I want to begin numbering nearer to the double covalent bond. So we have a group methyl on the third carbon atom and a double covalent bond on the first carbon atom, and the nomenclature is 3-methyl-1-butene. If I take the same chain, but I want to change the position of the methyl, and I want to put it on the second carbon atom. Okay, I respect here the position of the double covalent bond. I put it on the first carbon atom, but I want to make the methyl on the second carbon atom, and the nomenclature is 2-methyl according to the position of CH3, 2-methyl-1-butene. Here I want to take the second chain. I respect the position of the double covalent bond, and I want to make a branch chain. I want to put a group methyl on the second carbon atom, and I want to begin numbering nearer to the double covalent bond, and pay attention here, and nearer to the group methyl. Because if I want to begin numbering from here or from there according to the double covalent bond is the same, but I want to respect the position of the methyl. I want to take near the number of the methyl must be the lowest number. So the nomenclature is 2-methyl, because the methyl is on the second carbon atom, and the position of the double covalent bond is also on the second carbon atom, and the nomenclature is 2-methyl-2-butene. Name the following compound. First, look at the longest chain so as to include the double covalent bond with the lowest number. 1, 2, 3, 4, 5, 6, 7, 8. And we begin numbering from here nearer to the double covalent bond. So the longest chain is 2-octane. The number of branches following alphabetical order, we have ethyl and 2-methyl. So according to the alphabetical order, we have ethyl, methyl, 2-octane, E and M, E before M. But 2 methyl groups are present. We have 2 methyl groups, so we must add di, because we have 2 methyl groups, and the nomenclature become ethyl dimethyl 2-octane. Okay, add number to each branch, separate numbers by comma. So IUPAC name is 4-ethyl. We put dash between the number and the nomenclature, and comma between the two numbers. Okay, so we put dash here between the nomenclature and the number, and here dash between the nomenclature and the number, and between the two numbers we put comma. Ethyl is on the fourth carbon atom, so we put 4 here, and we have 2-methyl dimethyl. The first is on the second carbon atom, and the first is on the second carbon atom, and the second is on the sixth carbon atom. So we have 2,6-dimethyl to represent the position of the double covalent bond. Draw the condensed structural formula of the following hydrocarbon: 2-ethyl, 5-methyl, 3-hexene. First we start by hexene. We have hexene and we have 6 carbon atom, and the position of the double covalent bond is on the third carbon atom. So we put the 6 carbon atom, and we put the double covalent bond on the third carbon atom. If we numbering from here or from there is the same, because the double covalent bond is on the middle, in the middle chain, in the middle of the chain. After we have ethyl and methyl, so we have ethyl on the second carbon atom and methyl on the fifth carbon atom. So we put ethyl on the second carbon atom and methyl on the fifth carbon atom. Check whether the name of the compound is correct. First, we must take the longest chain containing the double covalent bond. So the longest chain is 1, 2, 3, 4, 5, 6, 7, and not 6 carbon atom. So the longest chain is containing 7 carbon atom is a heptene, and we must numbering nearer to the double covalent bond, so we must numbering from here 1, 2, 3, and not 1, 2, 3, 4. Okay, so we have 2 group methyl on the second carbon atom and on the 5th carbon atom. So the nomenclature is 2,5-dimethyl, 2,5-dimethyl, 3, the position of the double covalent bond, 3 heptene. The general formula of alkene is CnH2n, characterized by the presence of a double bond in the carbon chain. Number the chain so as to include both atoms of the double bond, and begin numbering at the end of each chain nearer the double bond.
Thanks for your attention. إن شاء الله يا رب بشوفكم على خير. السلام عليكم.